My name is Yanchao Liu, Assistant Professor of Industrial and Systems Engineering at Wayne State University. I'm going to present our recent work on optimized air traffic management. Our research objective is to develop an air traffic optimization engine to enable large-scale deployment of drone delivery systems. I'd like to acknowledge my doctoral student Zhenyu Zhou, who contributed a great deal to the research. Despite the growing use of drones in recent years, most drone flights today require undivided attention of a human operator on the ground. As more drones enter the airspace, human-level response and dexterity are unable to cope with the unprecedented density and complexity of unmanned air traffic. The lack of scalable fleet control and traffic management capabilities hinders large-scale deployment of drones. We propose a decentralized air traffic routing architecture and a suite of optimization models to realize unmanned traffic management. The models are to be used independently by multiple agents operating their own fleets in a shared airspace. No complicated bilateral communication is required to achieve harmonious traffic outcomes. Therefore, the routing optimization model can be solved efficiently. Validation experiments show that the agent's computing time is consistently less than 1 second per scheduling cycle for up to 100 drones in a 500 by 500 service area. The system is going to be implemented in a cloud computing environment, which enables cooperations with other USS. We have implemented the models and algorithms on real drone platforms. What's shown here is a software-in-the-loop formation flying test, where the pilot controls an arbitrarily designated leader drone, while other drones in the fleet follow the leader's action and maintain a tight formation. The same multi-drone architecture has been validated to work in a field test using multi-rotor drones. In this short clip, the pilot controls the leader drone while 2 follower drones are led by the motion of the leader drone. Here's a compilation of simulated field demos. The drones are powered by autopilot firmware run on Pixhawk flight controller boards. The user interface is coded in an iOS app. We used quadcopter drones built in our labs. We also used open source software such as Flight Gear and Mission Planner to visualize flight status. In this simulation, food orders arrive randomly over time and space. Each dashed line connects an order's origin, the restaurant location, and the order's destination, the customer location. Orders are optimally matched with nearby vehicles, and the vehicle's flight routes are optimized to reduce delay and detour. The process is driven by a mixed integer programming model. It is useful for system design, algorithm testing, capacity planning simulation, and even for serving as a software core for real operations. Here's a screen recording of our fleet management app showing drone activities in a restaurant delivery scenario. Customers can order food from any restaurant in the neighborhood. The received orders are optimally assigned to available drones at the moment, and the drones will be guided by our routing optimization engine to ship the orders along the shortest path while maintaining safe separation with other delivery drones operating in the area. The whole process is automated, and the user inputs, such as authorizing takeoff and landing, are handled by a cell phone app. The app is able to facilitate multiple user roles, including restaurant owner, customer, and fleet manager roles. The key models and algorithms have been published on top-ranked journals, including Transportation Science, IEEE Transactions on Intelligent Transportation Systems, and Computers and Operations Research. We have built several prototype drones and developed a cell phone app to enable real-world drone delivery testing. We have also completed regional and national I-Core programs for customer discovery and business model validation. Finally, I'd like to acknowledge our sponsors. including the Wayne State University, Michigan Economic Development Corporation, Amtrak Advanced Transportation Hub, and the National Science Foundation. Thank you for your attention.